Hello everybody. Now we shall discuss about measurement of high resistance. Measurement of high resistance. Coming to the example for high resistance, insulating material. It is insulating material will be having high resistance. This is one of the examples of high resistance. Okay, so this insulating material will be having high resistance. Will be having high resistance. So now let us measure the resistance of insulating material. That is, indirectly you are going to measure high resistance. Okay, so let me take insulating material. This is the insulating material. This is the insulating material. Okay, now in order to measure the resistance of this insulating material, let me apply voltage. Okay, so what we do is, let me use two conductors. I am attaching one of the conducting plates okay, this is conducting plate now. Okay, so this is conducting plate. Conducting plate is connected to this insulating material. Okay, let me use another conducting plate which is connected on other side of insulating material. Okay, so now this is the second conducting plate. Okay, so now voltage is connected to this insulating material with the help of two conducting plates. Okay, now this is insulator. Okay, this is insulating medium, insulating material. Okay, this is conductor. Okay, this is what? This is conductor, conducting plate. Again, this is also conductor. Okay, between these two conducting plates, insulating material is present, insulating medium is present. Okay, this is insulator. Okay, this is insulator. Okay, now plus minus, this will be the direction of current. Okay, this will be the direction of current, right? Okay, then the direction of flow of electrons will be opposite to the direction of current. Okay, then electrons will be flowing from here to here. Okay, this end to this end. Okay, now electrons will be flowing in this direction. Okay, these electrons are flowing through the surface. Sorry, these electrons are flowing through the volume. Okay, these electrons are flowing through the volume of this insulating material. Okay, these electrons are not flowing through surface of this material. Okay, some electrons will be flowing through the surface of this material, and some more electrons will be flowing through the surface of the insulating material. Okay, as these electrons are flowing through the volume of the insulating material. Okay, actually we have to find out volume resistance. Volume resistance is nothing but resistance of this insulating material, but in addition to this volume resistance, we are going to have surface resistance. Okay, so these electrons, anyhow these electrons are flowing through the surface of the flowing through the volume of this insulating material. Okay, now what we do is, some more electrons will be flowing to the surface. Okay, these electrons are flowing to the surface. Okay, surface. Okay, this is surface. On its outer periphery of this block of this insulating material, electrons will be flowing from here to here. Okay, electrons which are in blue color flowing through the volume of this insulating material. Okay, electrons which are in red color flowing through the surface of this insulating material. Okay, that is, we are going to have two resistances. Okay, if I place ammeter, ammeter indicates IV as well as IS. Okay, then resistance will be, total resistance will be V by IV plus IS. Then you are going to have RV RS by RV plus RS, that is RV and RS in parallel. Okay, so through this insulating medium, some electrons will be flowing, that is, some electrons are flowing through the volume of this insulating material. So you are going to have volume resistance. Some electrons are flowing through the surface of this insulating material, so you are also going to have surface resistance. Okay, actually you are going to find this volume resistance, nothing but resistance of insulating material. Okay, so if Rs is far greater than Rv, if Rs is far greater than Rv, then total R will be Rv by Rs plus 1. Okay, if this is, suppose if it is infinity, if Rs is equal to infinity, then R will be equal to Rv. R will be equal to Rv. If Rs is far greater than Rv, then R is nearly equal to Rv. Okay, so Rs is far greater than means you can neglect this. If it is 0 means, okay, then R will be nearly equal to Rv. Okay, R is equal to Rv. So if Rs is far greater than Rv means R will be nearly equal to Rv. R will be nearly equal to Rv. Okay, if Rs is equal to infinity, then R will be equal to Rv. Normally we consider Rs is equal to infinity. In practical case, Rs is far greater than Rv. Okay, that is, you are going to have the circuit like this. You are going to have two resistances in parallel. Okay, this is Rs and this will be Rv. Okay, this will be Is and this will be IV. Okay, this is also called as IL. This is nothing but leakage current. IL is nothing but leakage current. Leakage current. Okay. Now let us consider coaxial cable. Okay, let us use coaxial cable, okay, or underground cable. Okay, here you are going to have conductor like this. Okay, this is the conductor. Okay, upon this conductor you are going to have insulating material. Okay, this will be insulating material. Okay, this will be insulating material. Okay, this is conductor. Okay, upon this conductor you are going to have insulating material. Okay, this will be insulating material. Okay, now upon this insulating material you are going to have another conductor, okay, which is placed upon this insulating material. This will be metallic sheath. Okay, so anyhow this is connector and this is also connector, okay, whereas this is insulator, okay, this will be insulator, okay. Now we are going to measure the resistance of this insulating medium or insulating material, okay. So what we do is, let me apply voltage, okay. We have two conductors, in between insulating material, okay. This will be the direction of current, okay. Now electrons are flowing from this conductor to this conductor, in this direction, okay. So this will be, anyhow this will be the direction of electrons, right? So electrons will be flowing like this through the volume, electrons are flowing through the volume, okay. Okay, then you are going to have volume resistance, okay. Some more electrons are flowing through the surface, okay. So let these electrons which are flowing through the surface, these electrons are flowing through the surface, okay. That is, you are going to have surface resistance also, okay. Now I have to eliminate leakage current, okay. This will be IB, this will be ISR, IL, okay. Then if I place ammeter in series with this, then ammeter measures IB plus IS, okay. So resistance will be equal to V by IB plus IS or IL. So I should eliminate this IL, okay. How can I eliminate this IL? By using guard wire, okay. By using guard wire I can eliminate this IL, okay. Coming to the front view of this insulating material, front view of this cable, coaxial cable, okay, you are going to have like this, okay. This is conductor, okay. This is insulating material, okay. And you are going to have one more conductor upon this insulating material, again here also you are going to have conductor like this, okay. Front view, this is, sorry, front view will be like this. Front view of this cable, coaxial cable will be like this. Okay, now electrons are flowing. These electrons are flowing to the volume, will be like this. Okay, these electrons are flowing through the volume. Okay, now we apply voltage. Let A is the, let me connect ammeter in series with this to find the current flowing to the circuit. Okay, so let me apply voltage. Okay, let V is the applied voltage to this circuit. You can also use voltmeter to know the applied voltage. Okay, so now these electrons are flowing to the volume. Okay, in addition to these volume electrons, we have surface electrons, that is electrons which are flowing to the surface. Okay, now let me indicate those surface electrons. Okay, these are surface electrons. Okay, you are going to have electrons will be flowing through the surface like this. Okay, these electrons are flowing through the surface. Okay, on the other side you are going to have electrons like this which are flowing through the surface. Okay, so here what we do is, I am using conductor. Okay, now see, without using guard wire, this is a circuit. Okay, so this measures IL plus IS. Ammeter measures IS plus IV, volume current and surface current, right? Okay, now what we do is, let me use conductor which is placed upon this surface. I am placing conductor. Okay, connected like this. Okay, now what will happen is, electrons which are flowing to the surface of this insulating material, after reaching halfway, okay, anyhow electrons will be flowing from here to here, right? Okay, after reaching halfway, these electrons will find low resistance path and flow through this conductor. Electrons will be flowing through the conductor. Electrons will be flowing through the conductor. Okay, then because of anyhow these electrons are finding low resistance path and current will be flowing through this path. Okay, then this will be what? This will be surface current. So surface current bypasses through this path. Okay, surface current bypass through this path. Okay, then this ammeter measures only IV. Okay, similarly we place another conductor upon this, and which is joined here like this. Okay, let this is IS1, this will be IS2. Okay, sorry, this is IS1 and this is IS2, then you are going to get total IST or IS. Okay, that is you are bypassing this surface current. Okay, this surface current will be flowing through this path, bypasses through this path. So ammeter measures only IV. Okay, so R will be equal to V by IV. This is nothing but RV. Okay, this is called guard wire. Okay, now use of guard circuit. What is the use of guard circuit? Okay, without using guard circuit, how circuit looks like? Okay, anyhow this will be voltmeter, sorry. Resistance to be measured is connected between these two terminals. Okay, now let me place voltmeter. This is the applied voltage. Okay, let me use micro ammeter as the current which is flowing through this will be very small. Okay, so without using guard terminal, okay, this is what, this is resistance terminal. Okay, then current flowing through this will be leakage current IL. Okay, without using guard terminal, the circuit looks like. Okay, this is without use of guard terminal. Okay, this circuit let this is circuit 1. Coming to circuit 2, if I use guard terminal, what will happen? Here this microammeter measures the current which is flowing through this is IR or IV. Okay, so ammeter measures IL plus IR. Okay, it also measures leakage current. Okay, this is leakage path. Okay, now what we do is anyhow this is microammeter. Okay, let R is the resistance connected between these two terminals. This is the resistance which is to be measured. Okay, let this is leakage path. The current which is flowing through this is IL. Now here what we do is, let me use guard terminal. Okay, this is guard terminal. Okay, now this ammeter, okay, the current which is flowing through this will be IL. Because of using this guard terminal, okay, IL bypasses through this path. Okay, it measures only IR. It measures only IR. Okay, so ammeter measures only IR. Voltmeter measures V, if this is V. Okay, then R will be V by IR. Okay, this is nothing but guard wire. Okay, this is guard wire. Okay. Coming to the first method used for the measurement of high resistance, let us look into the first method which is used for the measurement of high resistance. First method is direct deflection method. Direct deflection method. Okay. Here we are going to measure the resistance of insulating material, or here what we do is we consider cable, coaxial cable, to find the resistance of cable. Okay, first we have conductor. So this is connector. Upon this connector, you are going to have insulating material. Okay, this will be insulating material. Upon this insulating material, again we are going to have conducting material or metallic sheath. Conducting material or metallic sheath. Metallic sheath is nothing but conducting material. Okay, that is, this is one of the connectors, and here we have one more connector. Okay, two conducting materials. This is conductor. Okay, this is conductor. This is, sorry, this is conductor. Okay, this is also a conductor. This is metallic sheath. Metallic sheath. This is also a conductor. Okay, between two conducting materials, insulating material is present. Okay, this is insulating medium or material. This is insulating material. Okay, now what we do is, to know the current which is flowing through this, we place ammeter in series with this. Okay, now we use voltmeter. Let me apply voltage. The current which is flowing through this will be IR plus IL. Okay, now to eliminate this IL, what we do is, let us do one thing. Let us use guard wire. Okay, Anyhow, electrons are flowing, anyhow this is the direction of current, means electrons will be flowing like this in this direction, okay, through the volume. Okay, again you are going to have surface electrons also, right? So what we do is, so the current which is flowing through this will be leakage current IL. Okay, now the current which is flowing through this will be IV only, or IR. Okay, the total current will be equal to I. So here I is equal to IV plus IL, but current measured by ammeter will be equal to IV only. Then R will be equal to V by IR. Okay, so this current can be eliminated using guard wire. Okay, this is guard wire. Okay, this is about a direct deflection method. Okay, in order to find the high resistance, okay, we take voltmeter reading and ammeter reading. Okay, voltmeter reading by ammeter reading gives resistance measured value. Okay, now let us look into the second method, loss of charge method. Loss of charge method. We have switch. Okay, we use electrostatic voltmeter to measure voltage. Okay, here we use resistance to be measured is connected across, resistance to be measured is connected across capacitance. Okay, here we use capacitor. Okay, this is capacitor. Okay, resistance to be measured is connected across capacitor. Okay, here we use voltmeter to measure voltage across this capacitor. Okay, let V is the voltage applied to this circuit. Okay, this is switch S. Okay, first what we do is, first we close the switch. Okay, first you close the switch to charge this capacitor. Let this capacitor gets charged with voltage of V. Okay, so close switch S so that capacitor gets charged with the applied voltage, with V applied voltage. Okay, now what we do is, anyhow that voltage is measured by this voltmeter. Okay, now you open the switch, open the switch. If you open the switch, how circuit looks like? The circuit looks like, okay, you're going to have circuit like this after opening switch. Anyhow, voltage across this is V only. Okay, the moment you open the switch. Okay, now after opening the switch, this capacitor gets discharged through resistance R. Okay, so by opening the switch, capacitor is allowed to discharge through the resistance R. Okay, capacitor discharges through this path. Okay, that is coming to the variation of voltage with respect to time. Okay, before opening the switch, this is the voltage of capacitor. Okay, after closing the switch, capacitor gets charged with V. Okay, when you open the switch, capacitor starts discharging like this. Voltage will be decreasing with respect to time. Capital V is the initial voltage. Okay, what will be the voltage while discharging of the capacitor? V will be equal to capital V into e power minus t by RC. Okay, so this is the voltage across capacitor while discharging. V is equal to capital V initial voltage across the capacitor e power minus t by RC. So this is nothing but capital V by small v, which is equal to e power t by RC. Okay, ln of capital V by small v is equal to, apply log on both sides. Okay, ln of e power t by RC. Ln means log base e. Okay, so log base e v by v is equal to log e power t by RC base e, then log v by v base e, which is equal to t by RC. Okay, from this R is equal to t by c into ln or log base e, ln capital V by small v. Okay, this is nothing but, in terms of log base 10, this will be equal to 0.4343 t by c log base 10 capital V by small v. Okay, so resistance to be measured is equal to T by C into ln V by capital V by small v, which is equal to 0.4343 t by c log base 10 capital V by small v. Okay. Okay, next method is Megger. This method is not included in your syllabus. Okay, anyhow we will discuss about this in brief. Okay, normally we have a ohm meter to measure resistance. Okay, let me use this ohm meter, series type ohm meter. The circuit will be like this. This is the circuit of series type ohm meter. Okay, resistance to be measured is connected between these two terminals. Okay, voltage source is connected between these 2 points. Okay, this is R2, this is PMMC instrument. Okay, here this is R1, this R2 is regulating resistance, right? Okay, here what we do is, instead of using this battery, we use hand driven generator. Okay, this is hand driven DC generator. Okay, by replacing the battery with hand driven generator, we can measure high resistance. Okay, since a hand driven generator produce the required voltage, okay, battery will not give required voltage. By using hand driven generator, we can produce required amount of voltage. This generator is that generated voltage is sufficient to drive current in this circuit. Okay, so we use hand driven generator instead in place of battery. Okay, nothing but Megger. Okay, this circuit is nothing but Megger circuit. Okay, now the last one is mega ohm bridge method. This also not included in your syllabus. Okay, you're going to have mega ohm bridge like this circuit looks like. It is like a V-stone bridge. Okay, this is high resistance, so you're going to have guard terminal. Okay, this is guard terminal. You're going to have galvanometer or detector, okay, which is connected between these 2 terminals. Now voltage is applied between these 2 terminals. Okay, this terminal is connected to this. Okay, this is S, this is P, Q, R, S. Okay, under balanced conditions, R is equal to P by Q into S. Okay, if galvanometer shows null reflection, means the bridge is said to be balanced. Okay, if there is any leakage current, that leakage current is allowed to flow through this galvanometer. Okay, we have one statement: high resistances are constructed with 3 terminals. Okay, why high resistance is constructed with 3 terminals? Because to eliminate leakage current. Okay, this is guard terminal. Okay, 1 dash. Okay, this is guard terminal. Okay, in order to eliminate IL, to eliminate leakage current, we use guard terminal, we use extra terminal, that is guard terminal. Okay, that's why high resistances are constructed with 3 terminals. Okay, the third terminal is guard terminal, which is used to eliminate leakage current. Okay, thank you.